okay, we convinced our managers that we're going to go ahead and use SwiftUI, async await, combine, whatever you want to use. I would say a good point to start is just with 5 questions. The first one is one that I find very important, and is, would we use this technology if we started from scratch today? Also, what are downsides and pitfalls of the technology? So this requires you to do some research before you get started. Another thing to think about is, can we gradually introduce this technology? Does this fit our vision and best practices? And this is an interesting one. And also, does the technology solve a problem that we have? And if all you're saying is, well, it's new, so it's kind of cool, that's not a huge selling point if you're not solving anything. Welcome to this talk called Warning New Technology Ahead. I'm not going to be announcing any huge new technology. We're actually going to be talking about what happens when we see new technology on the horizon. Because as developers, we love exploring generally. Many of us are a very curious kind of person, and we love to tinker and play around and kind of look at new technology and go, how can I use this? Or some of us even go, how can I abuse this? How can I make this do something it's not supposed to do? Just the other day, I saw somebody that figured out how they could, in iMessage, that little effect you get when you send somebody a picture with the hidden effect? Somebody kind of figured out how to access a private API and apply that to any image in their app that they wanted. Kind of cool. Like to me, that's peak developer, just sort of poking, prodding, see what you can make stuff do. And I mean, some of us even go further and we build whole apps or systems just for fun. I mean, Marin showed some cool examples where he's just like, hey, you know what? Let me kind of make a cool debugging tool for the simulator. Why not? Just see how far I can push that. Right? And the coolest thing about that kind of stuff is that there's no constraints. We can use whatever technology stack we want. We can use SwiftUI, React Native, Flutter, even though we might not like those technologies. If you want to try them, you can do it on your own projects as much as you want. But then, we do this stuff at night and in a weekend, so eventually we sleep, we wake up, and our working day starts, and all of the freedom is gone. We're at work, and now we cannot make our own decisions anymore because the business goals and the technology goals that we as people have might not line up. Sometimes they might kind of line up, but otherwise they might not line up at all. So, we kind of escape that a little bit. We go to social media because that's the perfect place to find reasonable, nuanced takes that we can use to convince our managers that we should actually adopt this new technology that I've been using all weekend. So we go online and we see all you need is SwiftUI. So maybe this stuff is not quite balanced because there's no nuance here. It's just somebody yelling like, learn SwiftUI 100%, and then we have someone like Marin up here who spends 40 minutes explaining, well, maybe SwiftUI is not all you need. It's a lot of what you need, but maybe it's not everything. So then we see that tweet or that post on Mastodon or wherever we are, and we see somebody who goes, no, ignore SwiftUI, it's buggy, we don't want to use it at all. So okay, yeah. For any opinion we might already have on any technology that we want to use, we're probably going to be able to validate that on social media. So that's not the best place to validate anything. I mean, it's great for your morale to see somebody say the thing that you were already thinking, but imagine walking up to your boss and going like, hey, you see this guy, he tweeted this, and like these other people are agreeing like, this is totally what we should do, and then your boss goes, well, there's like 50% of people that disagree, so yeah, let's not base anything off of social media when we talk about new technology. Because the fact of the matter really is that some businesses don't chase new technology. Right? I went freelance about 2 years ago, and one thing that I learned very quickly is that every client I have, every time I'm brought in to do some consulting, the business is very, very different. There's no one template that I can apply to every one of my clients. Some of them are very big, some of them are very small, right? Some might have a huge technology team of maybe 20, 30 people. Others might be outsourcing up until now and looking to hire their first people. But the one thing they all have in common is they need reliability. Right? They can't just go around and try random things. Because at the end of the day, they have employees, they have goals, they have growth needs. So they need to kind of know what they're doing. And reliability doesn't mean it has to be stable 100% of the time, or it has to be this or it has to be that. Generally speaking, what I mean when I say a business needs reliability is the business needs to be able to understand what they're spending money on, so what they're letting their engineers develop, what they're letting us explore, and what they're going to get in return. So that doesn't mean that a business will never allow us to explore technology, but if we ask our managers for time, we have to be able to tell them, like, this is how much time I would like to use on that, this is what I think will happen, and all that kind of stuff. The better we are at communicating this, the more reliable the experiment becomes to the business. What's funny as well is that I'm still teaching companies Combine at this time, for example. Right, so we as developers are already saying, oh, Combine? No, that's so 3 years ago. We're doing Swift concurrency now. We don't need Combine anymore. But a lot of businesses are still asking me, like, hey, can you come in and do a workshop on Combine for us? And that's not because they are 100% convinced that they're going to use it. It's more that they're like, okay, Combine's been around for a while now, so the most pressing issues have been removed or found by other people. So let's bring in somebody who knows this stuff that can tell us about the problems. And often when they ask me to do Combine, they go like, well, can you also tack on some Swift concurrency, do some comparisons, and help us understand which technology we should use where? And at the end of the day, some of them say, well, we're going to go all in on Combine. Others say we're not going to do anything for a little while, just because it may or may not match their goals. So let's say we have gone through some process and we decide, okay, we convinced our managers that we're going to go ahead and use SwiftUI, async await, Combine, whatever you want to use. Could also be an older technology like Core Data. For example, you might say, hey, let's take something that's been around for a while, but introduce it into our code base as new. So how do you do this? How do you approach that in a reasonable and effective way? And I would say a good point to start is just with 5 questions. And why 5? Because I like the number 5, 4, 6, I prefer them less. So I came up with 5 questions to ask. There's probably a million that you could ask. And the first one is one that I find very important, and is, would we use this technology if we started from scratch today? If you're looking to introduce SwiftUI, and I would tell you this is a greenfield project, you can start today, would you pick SwiftUI? And you would say, oh, probably not. Why would you introduce that into your existing project if you wouldn't even want to consider it for something brand new? And so that's a good one to start. Like, if you wouldn't use it for something new, why is it for something old? Also, what are downsides and pitfalls of the technology? So this requires you to do some research before you get started. And some technology is stable and it works well, but maybe it's very new and there's only 5 people in the world that know everything about it. That could be a huge downside if you're looking for something that you're going to use for a very long time. You want to maybe have some community backing, or maybe you don't. Right? That's something to consider for yourself. Another thing to think about is, can we gradually introduce this technology? If you have to refactor everything you're doing, maybe even do work on the back end just so you can try something new, you might want to reconsider. Does this fit our vision and best practices? And this is an interesting one. If you modeled your entire application on using stuff like RX Swift, then it might not make a lot of sense to move to async await, because everything you're doing is modeled behind reactive programming. So shifting from that paradigm to something new is more than just introducing some new syntax. It's going to require you to re-architect a lot of what you do. And also, does the technology solve a problem that we have? I've seen people try to introduce stuff for the sake of introducing it, which can be fine, but it's also the one counter argument that somebody is going to give you. It's which problem do we have that we're trying to solve by using this? And if all you're saying is, well, it's new, so it's kind of cool, that's not a huge selling point if you're not solving anything. And if you ask yourself these questions, you're often going to find that for some of them you're going to say, I don't know, or no, it's not solving anything, or no, it doesn't fit. And that doesn't mean that you cannot proceed. It just means that you're going to have a little bit of a harder time actually performing your migration eventually. Because the real goal of asking yourself these questions is not to sort of mark everything and go, okay, we meet all the requirements, we can start refactoring. It's more about finding your risks and finding out what the scope and opportunities are for what you're about to do. So you've decided to proceed, now what do you do? Right? You've decided we're going to go for async await fully, and we're going to do everything we can to use it. Now what? And so here's a couple of lessons that I've learned from doing consulting on what not to do. Jump in without a plan. I've seen companies basically go in and say, oh yeah, we saw SwiftUI, so we replaced like one table view cell with it. We loved it, so now we're doing like a whole screen. We kind of like that too, so now we're doing half the app just in one go. Let's do it. Also, don't replace all your code. Like sometimes you might go in and go, oh, we're just going to do this huge refactor. We'll still do like feature development, but kind of merge everything in. But we're going to replace everything from the ground up, all in one go, ideally. Also, don't tell product you only need like a week. I've seen this happen where, not literally a week, but someone's like, oh no, it's like if we can do this in this quarter, like we'll experiment, we'll learn, we'll implement it, and by the end of the quarter, we'll have a huge proof of concept where we have like half of the app refactored to SwiftUI, and we'll do the other half in like 2 months because we are so smart now. The project lasted for about 15 months, so nobody was quite happy at the end. Also, don't write only your new features with the new technology. This is maybe a bit of a hot take. I've seen people do this, and sometimes this works, but often what I see is that you kind of end up with the old stuff, and then you implement a new feature, and you're like, okay, so that needs something from my old stuff, so I'm going to refactor the old thing. Oh no, I can't, because the old thing also depends on it, so I'm going to refactor both screens. No, I don't have time for that. Okay, let me just make a quick shim around the old thing, and then do the new feature with the new thing, and it kind of works, but now you're sort of getting yourself into a worst of both worlds situation, where you were hoping to get the best of both worlds. You should, however, start by learning, and this is something that I have seen companies forego. A common strategy I've seen, and especially larger companies, is they will pick maybe 2, 3 senior developers, maybe some level 4 or 5 developers, whatever, 1 junior, and they'll have like a little working group. And the working group goes out and they build a couple proof of concepts. They go and learn this thing. And then they come back to the team, maybe the team's 20, 30 people, and they say, this is great, we're going to use it. We're going to go all in on that. And they kind of started, the refactor begins, and they kind of forgot to train the rest of the team. So now you have a couple of experts and a lot of novices trying to make something work, and it usually doesn't end well. So what I recommend on that is learn. And I know that we as developers love our focus time. We love to put our headphones on. We love to like dim the lights a little, put on our LED strips, and like go into like the matrix essentially, and get our flow on. But honestly, learning together is so much better than learning alone. I've seen people learn on their own, and some people are really good at that. But if you, as a senior developer, even if you're maybe like the lead developer of your team, pair up with one of your junior developers or another senior developers and learn together, because the other person is going to ask questions that you didn't even know you also had, and you're going to figure these things out together. And it might feel a little bit slower, but at the end of the day, when you walk out of your pairing session, you're like, wow, I actually learned way more than I thought I would. And it's also just more fun. Another way to learn together that I personally like a lot, and that's not because I teach a lot of workshops, but workshops are a good way to get your team together in a room. Maybe they haven't even met each other in person because everybody is remote, but getting them all in a room and learning together, making teams of 3 or 4 people and just sort of exploring technology, it's a lot of fun. And also the team sort of comes out stronger and smarter than they were when they entered the room. Another thing that you should always try to do is prepare your code base for a refactor. If you're starting to adopt new technology and your code base is not in good shape, your code base will not be in better shape at the end of the refactor, generally speaking. If you kind of identify the weak spots in your code base, maybe patch them up a little, maybe write down that you're going to replace that anyway, but at least you know that that's a weak spot, that will help you strengthen your code base in the end. Another thing that I would highly recommend everybody do is to establish API layers. This is going to help you determine where the impact of a refactor will be. If you're introducing async await, that's going to be a very different impact than SwiftUI, but you do want to know, where does async await start and end in my code base? What does it touch? What does it not touch? Same for SwiftUI. If I'm going to introduce a new UI framework, which parts of my code base do I have to refactor, and are these parts sufficiently isolated from each other that won't make it so that in adopting SwiftUI, I'm suddenly rewriting how I refresh authentication tokens in my networking layer? Because if you're doing that, you're probably sort of not having good API layers. This kind of a graphic might look familiar to a lot of us. I'm sure that I think Clean Code uses something like this, and I've seen similar graphics used in other architectures. But the point here is not to teach you like clean code or whatever, but to say a lot of apps will have something like this, where you can make these kinds of circles and say, oh, my UI is on the outside, I have like view models or whatever services or what you call them. After that, I have more low-level services, and on the inside, I have my core APIs that do file system interfacing, database interfacing, networking, that kind of stuff. And when you refactor these, you don't want to be touching all these layers at the same time. You want to go layer by layer. Because if you go one layer at a time, you make sure that you're not jumping into any rabbit holes. I don't know if you've ever tried, but one thing that I've tried once is to go, oh, you know what? I'll start with the networking layer, because that's a simple layer in my app, sort of not realizing that that's the middle of the app. So what happens is you're like, actually, I'll just do the screen where the user's favorites exist, and then I'll refactor the network call for favorites and kind of branch out into the view. And as I came out into the view, I went back into the networking layer, and I sort of started falling into rabbit holes, and instead of going layer by layer, I kind of went like crisscross across the diagram, because I had to rework everything, and I had to touch all the layers. And that wasn't pretty. And one way to realize whether you're about to do this is to go ahead and start small, right? So as I was doing that favorite screen, I quickly realized that my approach was not going to work very well, so I abandoned ship and I retried, and I started on the view instead. So if you have an architecture with several layers, if you hate the naming here, I really don't care. It's not the point. The point is there's a couple layers here. There's a networking layer, a data fetcher object, and a feed view model, right? And these work together, and these would all exist in different layers. Right? Using the layer in a view, nothing too fancy. It's a UI view controller, super old school. But this code should look familiar enough. So we have our layers, which is great. Where do we start refactoring this? And like I said, it might be tempting to say, I'll start with that networking layer that you just saw, because that's easy, that's small, that doesn't touch a lot, I think. But in the end, it does touch a lot. What you want to do is find places in your code base that you can refactor in a relevant way that depend on as little other components as possible. So when you're doing something major, like moving from combined to async await, it might actually make more sense to start at the view layer, because the view layer depends on something, but nothing depends on the view layer. If you start with networking, networking might not depend on anything, but a lot of things depend on it. So for example, what you don't want to do is something like this, where you refactor your networking code first. Because if you do that, everything that depends on networking must also change. Even if you think that only a couple places depend on that single API call, it will most often snowball into something much, much bigger, where you're now doing a lot of work, making enormous PRs that nobody wants to review, and it's just everybody gets unhappy in the end. So, looking at this graph, the thing that has the least dependence is the view layer. So we work our way in from the outside, because that helps us avoid branching out too much, and it allows us to focus on one thing at a time. If we start at leaves, like maybe a view model and the view, those two are often a one-on-one relationship in my experience, not 100% of the time, but often enough to make that a good pair to start. If we're introducing async await, we could actually say, you know what, my view model is going to get an asynchronous function load, and that function itself will still call my old code, but I'm going to use, in the case of async await, continuations to bridge into async await while still using the old code. So here I can start refactoring my view layer to be 100% async await without touching anything else. So I only need to update the view, which is really, really nice. But of course, in the end, I would like to write this. So in my load function on the view model, I don't want to use that continuation because that's more like a band-aid. So I want to start writing try await and then ask my fetcher to load the feed. And what's nice is that I can apply the same strategy on the fetcher. So on the fetcher, I can say that I will have both an old school callback-based load feed function and an async function. And the implementation of that can use a continuation to bridge my new API into the old code. So I'm still not refactoring everything. I'm still going layer by layer. I can now have stuff side by side. I can slowly start moving all my view models over to async. Once all the view models are migrated, I can go ahead and move the next layer and work my way in. As you can imagine, we can expand networking in the same way. And so now you might be thinking, well, okay, if you can have these things side by side, we could start at networking and start with the easy thing. And yes, that's true, but if you do that, you find that from networking, you're going to shadow into your next layer, into your next layer, into your next layer, and now you suddenly have about 5 layers where every function you have has 2 different versions. And you're going to be touching a lot of code, you're going to be making mistakes, and you're going to fall into rabbit holes again. So really, even though it feels very slow to start on the outside and move your way in instead of going inside out, in the end, slow and steady does win the race when you're introducing big new changes into a code base. And yeah, having 2 versions of API is great, I guess. The one thing you want to avoid when you have 2 versions of your API is you do not want to actually implement code in your shadowed API. Like, you don't want to duplicate your business logic. The only thing you should do when you're, for example, using continuations to go from callback-based to async await, is just call your callback-based function from the async function. Once you start duplicating business logic, all bets are off. You are going to make mistakes, 100%. You're going to have bugs where you're like, what, but this both refreshes a token? Why does it work on that screen and not on that one? Well, that's because you duplicated your business logic and you made a mistake by accident, and you completely overlooked that. So if you have 2 versions of your API, make sure that they all call into the same one canonical source of truth for your business logic. What about unit testing the new code? If I'm only allowed to call the old code from my new code while I'm refactoring, should I be writing unit tests for it? And I say, yes, you absolutely should. The reason why is because you're never going to have a better implementation for your unit tests than at that point, because you have the old code that you know works because it's been on a unit test forever, because we all write unit tests all the time, 100%. We never forget to do that. But if we have tests, and those tests are old code, and we write something new that only calls into the old stuff, we can just copy the same assertions over. And now we're testing the new API, which is actually, as an implementation detail, calls the old thing. But once you start refactoring the new method signature to actually use the new technology, you can keep your assertions and you can do TDD on that, which is very nice. And that's all great, and then your product owner comes by and they go like, but we are going to work on features, right? Like, we're not just going to be refactoring all the time. It sounds like a lot of work. We're going to do views, and then like, it sounds like we're not even going to have huge results all the time. Like, why are we even bothering? Why are we not just shipping more and more features? And the nice thing is that you can tell your product owner, I never said I'm going to stop building features. I said I'm going to make small changes over time to migrate into this new technology. So the first goal really is to wrap our code and to start moving. And we can still do features. There's no reason why we cannot do features. So that's kind of nice. So how and when do you decide that you should rewrite existing code? So I just showed you that continuation kind of approach where we shadow APIs. When do I decide that it's time to actually start implementing my async version of a certain method? Or when is it actually time to start fully going Swift UI on certain screens? And depending on what you're doing, deprecations can be a really good tool for this. So what I really like to do is, as soon as I make an async version of a function in existing code bases, where I use a continuation to call the old function, I deprecate the old function immediately. This will give me a whole bunch of warnings usually, but by the time that the warnings are gone, I know that I'm no longer calling my callback-based API other than from my async function. So that's how I know that it's time to actually refactor the async function, to copy the business logic over, and to rewrite that function into being fully async await friendly. Right, so once the warnings are gone, you rewrite the logic that you bridged earlier, which is very, very nice. And again, you'll be working from the outside in, right? And this means that you're making small changes over time instead of going into something big. Now let's talk about a very complicated topic for a lot of us. How do we convince a business that it's time to bump an iOS version? Right? Because SwiftUI comes out with a new version, we go, navigation stack, fantastic. Oh, iOS 16 plus. We were very lucky that Apple decided async await was going to back deploy to iOS 13 because a lot of us had iOS 13 as the minimum target at that point. So how do we convince a company to bump iOS versions? And that's not an easy task. It's actually a really hard task. And if you didn't do the research on the technology that you want to use, and if you don't know what the impact is going to be, don't even bother talking to your manager, because they're going to be like, I want to know exactly what we're getting ourselves into with this new technology and why it's worth bumping our iOS version for. Future proofing often isn't a very compelling argument. I actually had a consulting client a while ago, and they had a big chunk of Objective-C in their code base. And I kind of asked, like, so how many of the developers here know Objective-C? And they said, oh, there's only 4 of them in a team of 20. I was like, okay, that's not too many. Should we not refactor this Objective-C code maybe to Swift? And they kind of looked at me like I was crazy. And I realized, okay, well, this is going to be fun. So I was like, how often does this code change? And they said, well, nobody's touched it in 6 years. And then I knew, like, okay, so there's no point in changing this. And some of the juniors were like, oh, we should because I want to be able to work on it. And then they said again, nobody's touched this for 6 years. There's no need to work on it. It's stable, it works. And that was a very interesting sort of discussion to sort of see happening between the team, because a lot of them were like, we want to future-proof this, right? What if these 4 people go away? And they kept saying, like, nobody, like even the Objective-C people had no idea how the code worked anymore because nobody had to touch it. It was good, it was solid, it was finished, it was done. And then I realized maybe future-proofing is not the best argument to actually do a major refactor. This was a big piece of core business logic. It was very high risk to change it. They wanted to make sure that it kept working. And if something has been running stably for 6 years, why rewrite it to Swift if that means that we might introduce bugs, we're going to have to debug this, we're going to have to test this. It's going to take a while until we have Swift code that we don't have to touch for 6 years. I think nobody in the past 6 years has written any Swift code that they have not had to change since they wrote it. You also want to find out if the new technology that you're going to use improves development speed. Right? If something looks nicer, but everything is going to take twice as long, maybe the company does not want to use it. App stability and user convenience are great reasons to bump iOS targets. When I worked for Disney, for example, we often had to bump targets or kind of look at iOS bugs even. Like there were issues with iOS where we had to make a decision like, okay, so this app might crash if something goes wrong and we cannot do anything about it because it's a bug in iOS. We asked Apple, is there any way we can work around this? Apple goes, not really. Like, if you work around it, you're actually going to actively avoid the system fixing itself on the next iOS update. So yeah, what are you going to do about that? Coming back to your product manager and saying, you know this crash that's happening for like 1 in 50 users? We can fix it by bumping a minor version. And they would most often go, bump the minor version. We want to have less crashes. It's a minor iOS update, so obviously we're going to bump that. Major versions was a bit more of a pain, but if we can make a good case that the app's going to be more stable, the user experience is going to be much better, and we're not actually going to lose subscribers, that was an easier case. Of course, you can imagine Disney Plus did have a lot of sort of, oh, but it has to work on iPad mini kind of situations, but yeah, app stability and user convenience are good arguments to bump iOS versions. Also, you have to make sure that whatever you're going to refactor is proportional to what you're going to gain. Refactoring for 6 months, just so that you get 0.1% less crashes, that's going to be a tough sell, because that's one engineer at least sort of out of the running for 6 months, making changes to the code base. And if the goal is to solve only 0.1% of crashes, that's not great. If you can, however, refactor quickly and speed up developers 2x by doing 1 month of work, that's a great argument. So, you now have some sense of things you should or shouldn't do when you're refactoring. And one key thing to keep in mind, whenever Apple announces something new, we all want to jump on it and do that in your weekend time. That's perfectly fine. But if you're in a team, it's okay to take your time, even if the whole team is on board with going to Swift UI, with going to Swift concurrency, even if your manager is excited for this and wants you to go ahead and try it. There is no honor in being the first company that makes the biggest mistakes out there. It's perfectly fine to sit on ideas and thoughts and to sit on experiments for a little while to kind of see how they crystallize. It's perfectly fine to have an internal build of your app that uses Swift UI that never sees the light of day for users for like 6 months. Just wait for other people to try and fail So you can learn from them, and you can go ahead and go to production as soon as you know things are good. Also, it takes time to train a team on new technology. Some people see something and they immediately get it and they are off to the races and they're making amazing things. Other people need to spend some time with technology. Give the people in your company the time to learn, give them the time to practice, and don't push them to ship stuff if they're not comfortable with the new technology. These changes can sometimes be very big and really require good training. At the same time, that doesn't mean you should not take a little bit of risk, right? The biggest gains you can make as a team are when you're taking little bits of calculated risk. So you won't always get it right the first try. Even if you're taking your time, letting other people make the biggest mistakes, you might still get it wrong. But if you've trained your team, if you've investigated what you're doing, if you know what's happening, it's going to be much harder to see what went wrong and fix it. So definitely do take some risk. And just as Maren was speaking, I thought of this Steve Jobs quote, which I think sort of sums up new technology really good, right? See it, use it, try it out, make some mistakes, but not too many, but definitely don't be afraid to try technology. So in summary, new technology is great for us as developers. It gets us excited. We love doing our weekend projects. We love choosing whatever technology we want to use. We love going all in on whatever we want to make. It's fun. But at the same time, businesses have different needs from us as developers, as persons, right? A business needs to make sure that they can pay our salary, right? If they let us experiment with Swift UI all day, but they can't pay us, we're not happy, the business is not happy. So there is some friction there, and we have to find a good medium. Adopting new technology is a delicate process, often more delicate than you might think. I've definitely seen companies that are very excited about technology and kind of get a couple things wrong, and that really bleeds into team happiness, it bleeds into being late on deadlines, app stability suffers, everything kind of goes off the rails. So it's delicate. Make sure you take time for it. And this one I can't stress enough. It's kind of amazing to me sometimes how often it's done that a team has 2 or 3 people that learn the technology, are supposed to teach the rest of the team, but basically what they're just doing is go watch some YouTube videos, let's do it. So make sure the team learns before you use it. Refactor from the outside in. That really helps you keep tiny scopes. It helps you keep track of what you're doing. It helps you tell a product manager, hey, I'm spending another week on this view, and then we can ship it. Right? Being able to report progress is important. I've seen people refactor and go, oh, it's about anywhere between 3 and 6 months from shipping, and that's not a good report to give your product manager. They get nervous from that kind of things because they have goals to reach. And also, don't be afraid to be slow. It's perfectly fine to sit on ideas and thoughts, like I said, and to sort of let them crystallize before you go into the world. And before I wrap things up, if you like technology, you want to learn how to use it, I have a couple books out that you can look at. I have a new bundle, so check that out if you're interested in learning combine, concurrency, and/or core data. And I'd like to thank you for your time.